Hi class, this is Gigi from Kauai Community College. Talking about the chain rule here, and this is the chain rule card set number 14. So if you were in my class, these are the blue cards number 14. All right, so let's take a look. The first thing that I would like for you to do is to look at the structure of this function. Y equals sine of, so we would say sine of something, that would be the outside function. So you will have sine of something being your outside function, right? And then you would have the inside function here being sine of something, and then we have inside e to the x. So this is a double chain, right? A chain rule where your inside function has a chain, okay? So how do we deal with this? Same thing as before. The derivative of y with respect to x as our variable here is equal to the outside derivative. Okay, so that would be the derivative of sine is cosine, and we will keep the input as it is, which would be sine of e to the x. That is your outside derivative. Okay, multiplied by your inside derivative, and your inside derivative is sine of e to the x. So then the derivative of sine of e to the x will need to have you applying the chain rule there. The derivative of sine would be cosine of e to the x multiplied by the inside derivative. In this case, the derivative of e to the x is e to the x. And this is the derivative of the inside. So you can see that this inside function has is a composite function. So you have to apply the chain rule twice here. All right, that is it. And then you might ask, well, what can I do with that? Really, there isn't anything you can do with that besides writing it neatly. So dy dx is going to equal to, if you really have to, I would just write e to the x cosine of sine e to the x multiplied by cosine of e to the x. Somehow writing e to the x in the front make me feel better, but other than that, there isn't much you can do about it.